Domain and range of continuous graphs also has some special cases because your domain and range can continue forever in one or both directions. If we think about this on a graph, that's going to be used or shown using an arrow. If you sketch a graph, well, if it's got an arrow on one end, we know that it keeps going and going and going and going, even when it's off the page, even when those values don't exist. Or excuse me, don't exist on your graph. They exist because infinity. All right. So we have to think about what that arrow means. When does it stop? And in these cases, we may have a special case or special case solution known as all real numbers. And what all real numbers is telling us is it's similar to IMS. It is from negative infinity to positive infinity. Every whole number, decimal, fraction, irrational, or rational number. So it's literally all of the numbers, negative infinity to positive infinity, all real numbers. You'll often see it denoted with this funky looking R, in which case you just draw a regular R and put a bar on the back of it, and that means all real numbers. I would accept ARN or writing all reals, as long as you show you know you're talking about all of the numbers. Now, let's try a couple of these. If we look at our first graph, we're still going to ask ourselves the same question. For domain, we're thinking, okay, from left to right, let's get those numbers. Now, if we take our pen and we put it on the furthest point to the left, our x value right here is 1. So we know if we have from 1, 2, we then take our pen and we put it on the furthest right, except we see that the furthest point to the right, either one of them, isn't a point, it's an arrow. So what that means is it keeps going and going and going. And although, yes, this one is getting lower as it goes, it's continuing out. It's going to continue on in that outward direction forever. So we would say from 1 to infinity, because it's going to infinity. Now, when we write our compound inequality using that, I'm going to zoom in on this, I'm sorry. Using that infinity, we would set this up same as usual, 1 less than x less than infinity. When you write infinity, though, we can go ahead and just erase that. You're not actually going to write out the infinity. For me, it's helpful to write it out and then erase it. That way you know you've got the rest of your inequality set up correctly. We do need to check to see if our inequality needs to be or equal to. This is on the graph itself, which tells us this should be equal to. It is included. It is included. So all this statement is saying, you could write it the other direction, is x is all of your numbers greater than or equal to 1. It's all of your numbers above 1. So our domain is all of your numbers greater than or equal to 1. We're going to use our same idea with range. Except remember, range is we're going bottom to top. If we consider the bottom here, and we put our pin on it, oh, it's an arrow again. It's not a point. Also, this arrow continually goes down. It's going to keep going down forever. So our bottom, it's going on forever and it's going down forever. We call that negative infinity because it is down. It's the negative numbers. So we'd say negative infinity, 2. Do the same thing for going up. Our highest point is also an arrow. It's going to keep going to infinity. Here we just say infinity because it is positive. So from negative infinity to positive infinity. We just talked about that we would call that all real numbers. Now that we've looked at this first one, let's go ahead and you try the second one. Think about for domain, left to right, and for range, bottom to top. If it helps, practice doing that each time. Write that number phrase. So domain, we would look at it. We're going furthest to the left, which would be right here. It's an arrow. It's going to keep going out forever and ever and ever. So we would call that negative infinity because it is the negative x values. 2, we got an arrow. It's going to keep going out forever and ever and ever. So this is positive infinity. From negative to infinity to positive infinity, we call all reals. We're going to approach our range and we're going bottom to top. Our lowest point would be right here at this turning point. Well, the x value at this turning point would be 0. So our bottom would be 0, 2. We look again at our top. Our highest point is an arrow, which tells us that it keeps going up and up and up to infinity and beyond. So we have 0 to infinity. We would set our inequality up. 0 is less than y, which is less than infinity. We know that 0 is on the graph, so that is equal to. And we remember, hey, we don't actually write that less than infinity. It's understood. It's given. So we would say 0 is less than or equal to y. Or you could write that single inequality statement as y is greater than or equal to 0. Lastly, we're going to do the same thing. Domain, left to right. When going left, we look to our furthest point. We notice it's an arrow, so that's going to give us infinity. This is negative infinity. Our furthest point to the right is also an arrow. It's going to the positives though. So we have negative infinity to positive infinity. Infinity to infinity tells us all reals. We do the same thing with our range. With range, we're going to say bottom to top. Here we would have it going down forever, so that would be negative infinity. 2 going up forever, that would be positive infinity. So here we would have all real numbers.